So this is a half-wave rectifier. Okay. We're gonna try this circuit first with the switch is open, so we can see a flat DC in the output. Then we will close the switch so the capacitor can discharge some of its charge. One note here: you can use this input. I have some problems with normal power DC AC input, which is 630 is 110 RMS. This guy is much easier to use, okay, because you can set, instead of setting the RMS and convert to max, you know, it's easier just to set the peak to 15 and that's it. Okay. Okay, so yeah, so let's try the circuit with the switch open. So let's see. Looking for here. Yeah, the input and the output. So the input is here, this guy. This is the input. And the output should be this guy here. So see, guys, the output is just constant. Okay, and you notice it's not equal to the output. So this value. So if we move this stuff here, so the maximum of the input should be 15 or close to 15. Oh, so look, around 15. Okay, but I don't know what happened. Yeah, but this guy is not exactly 15. It's smaller than 15. Look, it's a DC. And it's just one value here, 14.6. So the drop on the capacitor is not 0.7, it's something smaller than 0.7, but there is a drop on the capacitor. So let's make, maybe if we make it 5, yeah, it will be much clear for you. Yeah. You can even set at AC. If we set at AC, it will just go, so that's fine. Okay, guys, so just measure the input max and this DC value, and the difference should be 0.7. Not 0.7. 0.7 is just actually a model for any diode, but for this particular diode, the drop at this input voltage was around 0.4 or something. Okay, so measure these two values. Then if we close the switch, now there is a path for the capacitor to discharge. Then wow, let's see, yes. And here is the ripples. Okay, we charge, discharge, and see that this discharge is just a straight line. Because I choose here R is big and you know C is big, so just a straight line. Then it goes high, then it's charge again, discharge, charge, discharge, okay, and so on and so forth. Okay, you can okay, let's concentrate on that one. Okay, so one trick here to measure the peak to peak properly, if you do like this, it will disappear. You know why? I will let you know why. Just think about it. It's clear, okay? But one way to measure it properly is to draw it as EC. So DC means it's a direct connection. Means whatever comes in the input of the oscilloscope or the channel, just blow it on the screen. EC means remove the DC shift from the input. So if we remove the DC, it will just be like this because there is no DC. So We just bring it down. Why we bring it down? So when we make it like this, it will not go away like in the beginning. Okay, now you can have this guy here, you know, and set it to whatever B. Okay, and you can measure the peak to peak voltage. So this is the maximum now, approximately the maximum, and this is the minimum. Wow, it's not good. Yeah. Oh, okay, this is the minimum, and this is the maximum. So the minimum is minus 1.7, and this is the difference, 3.59 volt. Okay, take this value and compare it to the theoretical value, which is Vmax minus 0.7 over RFC or FRC, whatever. Okay, they should be close, but they shouldn't be equal. Remember, this formula, which is Vmax minus 0.7 over FRC, is approximate formula. And we have actually two approximations, not just one, two approximations. Okay, and these two approximations, you know, make it not that, you know, accurate, and you will see that there is a big difference between them, especially if you have a smaller tab. Okay, so for let's now change whatever. For example, let's change, yeah, let's change this guy here. So it was 3.9, right? The peak to peak, the rebel peak to peak was 3.9. Anyone remember here? Yeah, 3.6. Okay, 3.6. So let's change this to 1000 microfarad. So the double, which is just 1 millifarad, 1000 micro. So let's see. The rebel should be smaller, and that's obvious now. You see, guys, it was spanning more than this in the beginning. Now the rebel this is two divisions, and we have here one, so just 2 volt. It was 3.6 when we have 470 microfarads. When we increase C or the tau, the what? Yeah, the rebel become less. It's now 2. It was 3.6. Now it's 2 volt peak to peak. Okay, so guys, follow the manual for experiment 1, and after 10 minutes, I'm gonna choose one of you guys, so he can tell me the value he got, and and he should also calculate the value and the error. And one last thing he should do also is to calculate the VDC. So something I forgot here is that we can measure actually the DC voltage. So we can insert a meter here or multimeter. Yeah. One trick, if you have a voltmeter like this or a multimeter, okay, that measures the voltage. If you have an AC signal and you want to measure the DC content, you remember, guys, V maximum over pi, this DC stuff, this average value, okay, you can measure it using multimeter. Just set the multimeter to a voltage, of course, and DC voltage. Then and connect it to the AC source that you have, and that AC source should have, for example, some DC content. So the voltmeter or the multimeter will measure for you the DC component or the average value of this output. So instead of having variable VDC equal to variable VO max minus variable peak to peak over 2, we can just measure it using a multimeter like this, but set it to volt and DC. This is AC, this is DC. Okay, and it will measure for you the DC content or the DC value. Then compare it to let's compare it to the one that I just mentioned, which is VO max minus variable peak to peak over 2. They should be close. Okay, but again, not identical, because again, variable peak to peak formula, which is Vmax minus 0.7 over FRC, is approximate formula. Okay. So guys, do that. Okay. And after 10 minutes at 11:20, I will choose one of you. He should give me, let me write them down for you. So tools, there is a text box here. Can insert the text box. Yes. Yeah, so measure number 1, measure the DC output when switch is open. Number 2, close the switch. Measure variable peak to peak when capacitor is 1000 microfarad, and another measurement at 470 microfarad. 2 times. Okay. Then compare to variable peak to peak equal to Vmax minus 0.7 over FRC. F is 60 hertz, and here is R 100, and C will be once 1000 and once 470 microfarads. Okay, then 4, measure DC voltage, DC, or the average value using multimeter or voltmeter, whatever, that's fine. You can use any. And number 5, compare to VDC equal to VO max minus variable peak to peak over 2. Again, in 2 cases. So a lot of measurements, but they are very easy. Okay. So I will give you until 11:30. That's fine. So until 11. Anyone got stuck or something? Should we continue? Okay. So let's go to the follow rectifier.
Yeah.
So I just constructed this circuit here. Okay, run it, and just be sure this is 15 volt and this is 60 hertz. Okay, we forget to do that. And now, yeah. So this is the input, which is the orange. Yeah, let's hide it for a moment. And this is the output. So the positive half cycle buzzed, but the negative is flipped. It's not like the half wave. The negative is just, disappear. No, and here is, guys, the 1.4 stuff. It's clear here with the full wave rectifier, and it was also smaller V maximum. Last time it was not clear because the V maximum was very high. It was 155.5. Now it's just 15. So it's clear now there is, this small gap in which the diodes are off. Okay, and also it's clear the difference between the input and the output maximum. So this is 15. This is 15 minus theoretically 1.4. Here it may be 1 volt or something. Okay, just measure it. Okay. So guys, now gonna start this circuit, measure VO max, V input max, which is 15, V output max, which should be theoretically 15 minus 1.4, and measure also the DC output, which is theoretically 2 Vmax over pi. In half wave rectifier, it's Vmax over pi. In full wave rectifier bridge, it's 2 Vmax over pi. So this value here theoretically is 2 multiplied by 15, 15 minus 1.4. This is Vmax over pi. Okay, you should get something like a theoretical value, 8.6 or something. Okay, because there is still approximations, and basically this approximation came from that we assume when we do the integration that the output signal is just like the input signal in the positive cycle, but it's not exactly like it. Okay, you see guys, there is a difference here. And we also assume that there is no periods of these periods here in which the diodes are off. That's also, you know, a source of the error between the measured DC value and the theoretical DC value. Okay, so guys, again, measure VO max, V input max, VO max, and VDC, and compare this VDC to Vmax over pi. You have 10 minutes until 11:53. Okay. Any questions? It's easy, especially for this circuit. It's an easy one. So let's continue with the third. Third experiment. We have the full wave with capacitor. Okay. So firstly, open this switch, make it open, and run the circuit. You should see nothing like this. Okay, so let us see. Oh yeah. You should see a stable output, stable DC output. And this output is actually 13.54. Okay, because this output is actually Vmax minus 1.4 theoretically, which is approximately 15 minus 1.4, 13.6. We have here 13.54, which is good. So this is the output. This is actually the capacitor has charged until 13.5, which is Vmax minus 1.4, and just stops. There is no more charging or discharging. That's why it's completely DC. Okay, then close the switch, stop that guy, and run again. Now you have, of course, if it's a DC, let's draw them together. Yeah, 10 and 10. Yeah. So this is actually the input, which is the orange or the yellow, whatever, and the output is the red one. Here is the rebel, very clear. Now let's bring this to 0, and then you can measure the variable peak to peak. Redo exactly the same steps that we did for the half wave rectifier. Okay, measure the variable peak to peak. Okay, calculate the DC and measure the DC. Okay, from the multimeter. Calculate the theoretical values and compare, and this should be done twice at C equal to 1000 microfarad and C equal to 470 microfarad. And of course, at C equal to 470 microfarad, the rebels should be more. Okay. You have, guys, 50 minutes until 12:25. Let me add very quick the multimeter.